Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at St. Andrews Institute of Technology and Management, Gurgaon. This college is affiliated to Maths Dayanand University, Rohtak. So today our topic will be GCD and Euclidean algorithm. So topic Euclidean algorithm. From this topic, there will be a 8 marks question asked in your final semester exam. So I will discuss that question. So how to solve that question. So this is your 4th unit topic. So first GCD and LCM I will discuss. After that, I will define Euclidean algorithm. So first there is a common divisor topic. So just let's see common divisor. You guys have already read this topic in basics 7th, 8th, and 9th standard. So just the same as it is. What is common divisor? So if a number C divides any two numbers A and B, if a number C which divides any number two numbers A and B, it means if C divides A and C divides B, then C is known as common divisor of A and B, right? So simply we can say that C divides A, C divides B. That means there is a number which are dividing both of these number. That means C is the common divisor of A and B. Now GCD. So what is GCD? If a number D divides two number A and B and is divisible by all the common divisors of A and B, then D is called the GCD of A and B is denoted by small bracket A comma B, right? If a number D divides two number A and B, that means and is divisible by all the common divisors, and that number is divisible by all common divisors of A and B, then D is called GCD. So there is a notation here, small bracket A and B, right? So there is an example, then you will better understand by this example. GCD of 8 and 24 is 8 and is written as 8, 24 is equal to A. As we know that 8 is the number which divides 8 divides 8 and 8 divides 24. That means 8 is the number that are dividing both of these numbers. So GCD will be your 8. Minus 6 and 0, so 6 divides 6 and 6 divides 0. So GCD will be 6. 5, 10, 25, so 5 divides 5, 5 divides 10, 5 divides 25. So 5 will be GCD. Right, there is a note here that GCD of AB is equal to GCD of BA. That means if GCD of 8 and 24 is 8, then we can say that the GCD of 24 and 8 also be 8. So both are equal. If A divides B, then GCD of B is equal to A. So here just suppose 8 and 24. So 8 divided 24, that means GCD will be 8, right? There is a theorem on GCD. So just look at this theorem, guys. Remainder theorem. So this theorem is related to remainder theorem, right? So actually remainder theorem we have. So if A is equal to BQ plus R, BQ plus R means A and B are two numbers, R is the remainder and Q is the quotient, right? So if A is equal to BQ plus R, then GCD of AB is equal to GCD of B and R, right? Both will be equal. It means GCD of A and B is the same as the GCD of B and R, where R is the remainder obtained by on dividing A by B, right? That means if A is equal to BQ plus R, this is a number, and then AB is equal to GCD of A and B GCD of B and R both are equal. and where R is the remainder on dividing A and B. So there is a proof, and a proof is here. Actually, we will use this theorem. So I am just telling you this theorem. Proof is not be asking in our final semester exam, but in Euclidean theorem we will use this theorem. So I am discussing this theorem. So proof of this theorem is here. Let GCD of A and B we are considering D1, right? And GCD of B and R is considering D2. And we have both of the GCD are equal here. इसका मतलब क्या हुआ? It means that GCD of AB is equal to D1. So therefore D1 divides A and D1 divides B. Means अगर इन दोनों का GCD D1 है, that means D1 divides A, D1 divides B. Then we can say that GCD of A and B is equal to D1. So D1 divides D1 divides A and D1 divides B. So by the theorem, it means we can say D1 divides A minus QB. This A minus QB. D1 divides A minus QB. By the theorem, if A divides B, A divides C, then A divides Bx plus Cy for integers values of x and y. That means D1 divides A minus QB, right? And A minus QB is equal to R. That means D1 divides R. So now D1 divides B and D1 divides R. This implies D1 is the common divisor of B and R. D1 divides here D1 divides B and D1 divides R. That means we can say that D1 is the common divisor of B and R, right? Now there is a line here. D2 is the GCD of B and R, right? This point, D2 is the GCD of B and R. That means D2 divides B, D2 divides R. Here D1 divides B and D1 divides R. It means D1 divides D2, right? Since D2 is GCD of B and R. If D1 divides B, D1 divides R, D2 divides B, D2 divides R, that means D1, D2 will also be divisor of each other. So D1 divides D2. Similarly, we can prove D2 divides D1, right? So D1 and D2 and D1 divides D2 and D2 divides D1, where D1, D2 are the natural number. Therefore, D1 is equal to in D2. So hence, GCD of A and B is equal to GCD of B and R, right? Euclidean algorithm. So Euclidean algorithm, the algorithm used for finding the GCD of two positive integers. So where we will use this algorithm to find the GCD of two positive integers A and B is called the Euclidean algorithm, and it may defined as let A and B be positive integers, right? So A is equal to BQ plus R. Remember this term, A is equal to BQ plus R. That means A and B are two numbers, Q quotient and R is the remainder, right? So let A and B be positive integers. Then by division algorithm, we are taking R1, R2 and so on Rn be the successive remainders. So we can write A is equal to BQ plus R as A is equal to BQ1 plus R1. So 0 is less than R1 less than B, dividing A by B. Now just look at here. To solve this algorithm, A is equal to BQ plus R1. This is your first step, right? Now we are taking B here. So you will write B is equal to R1 into Q2 plus R2. That means you have to write your B, means B means other number, in the terms of R1, new quotient Q2 and new remainder R2. So you will write B as R1 Q2 plus R2. 0 is less than R2 less than R1. Now third step, you will choose your R1 from here. R1 here, and you will write R1 as in terms of R2 and new remainder R3, right? So R1 you will write R2 into new quotient Q3 plus new remainder R3. In next step, you will choose R2 from here. So R2 means remainder. R2 you will write in terms of R3. So R3 into Q4 plus R4, right? And so on. That means you will, in your next step, you will choose R4. That means R3 from here. So R3, you will write R3 in terms of R4 into Q5 plus R5, new remainder, right? Plus and so on. In the last step, we will get Rn minus 1 is equal to Rn into Qn plus 1 plus Rn plus 1, where 0 is less than Rn plus 1 less than Rn, where R1, R2, R3, R1 is greater than R2, R2 is greater than R3, and so on, is a set of decreasing non-negative integers, and this process must terminate after a finite number of steps. That means in the last step, if we are getting Rn plus 1 is equal to 0, then our process will be stopped. And Rn minus 1 will be, we have Rn minus 1 will is equal to Rn into Qn plus 1. This implies Rn divides Rn minus 1. So GCD of Rn minus 1 and Rn will be Rn. So we can say that GCD of A and B is equal to GCD of B1 R1, GCD of R1 R2, and so on. GCD of Rn minus 1 Rn is equal to Rn. Hence GCD of A and B is Rn. So guys, just try to understand this algorithm, and this algorithm proof अभी तक तो नहीं आया हुआ एग्जाम में, बट इसका एक क्वेश्चन हमेशा आया है, तो आप लोग उस क्वेश्चन को अच्छे से समझिए, right? So there is an example here. So this is your 8 marks question, and always this type of question always asked in your final semester exam. So find the GCD of 595 and 252 and express it in the form of 252m plus 595m, right? So first we need to calculate GCD of these two numbers. So for the GCD of these two numbers, 595 and 252, which one is the smaller one? 252 is the smaller one. Which one is larger? 595. So we have to write our larger number in terms of the smaller one, right? So 252 is the smaller number, so we will divide 252. We will divide 595 by 252. So 252 divides 595, it will be 2 times, that means remainder is 91, right? So quotient is 252. So A is equal to 595, B is equal to 250 here. So A is equal to BQ plus R means remainder. So remainder is 91 here. So remainder R is equal to 91. BQ means B is the number 252 and Q means quotient is 2 here, right? So we are writing our given numbers in the is in the Euclidean algorithm form. So A is equal to BQ plus R. A is 595, B is your second number 252, and quotient is 2, remainder is 91. Now other step, you will choose our number B, and you will write B as a new quotient plus new remainder. So just choose B. B is your 252. So just next step, you will write 252 here is equal to your 91 is the remainder first one. So 91, and you will divide 91 252 by 91. So 91 divides 252, it will divides 2 times, and your remainder will be 70 here, right? That means we have to just follow up our process. We will repeat our process again and again and choose B from here. So you will write B in terms of AQ plus R. That means this is your new remainder 70 R2, and this is your new number, and quotient is Q2 here. Now again we will choose our B from here. So our B is 91. That means this is your Q1, R1. So write R1 91 is equal to remainder is 70. 71 divides 91. Then you will get remainder 21 here. So 21 plus, it will divide 70 only one time. So quotient is 1 into 70 plus 21. And next step you will find 70. So write 70 in terms of 21 and 21. So 21 divides 70, it divides 3 times. So quotient is 3 plus remainder is 7. Now write 21 as in terms of 7. So 21 you can write 7 into 3 plus 0 is here. Now in last step you are getting remainder 0. So our target is, if we are getting remainder 0, then last step is will be your GCD of that two numbers. So GCD of 595 and 252 is 7 here. This is your last remainder 7, and last remainder we are getting 0, and second last is your 7. So GCD of these two numbers will be 7. Now first step of this first point is solved. Now second is express it in the form of this one, right? So for the expression of this we will see our equations. So last equations, second last equation is 70 is equal to 3 into 21 plus 7. So we need to find the value of the remainder from the second last equation. So 7 is equal to 70 minus 3 into 21. We will find the remainder value from the second last equation. So 7 is equal to 70 minus 3 into 21. Now 7 is equal to 70 minus 3. You will calculate the remainder value 21 from the equation third. That means if we will find the remainder values one by one from the equations. So first we will calculate 7. We need to write the value of 7. That means remainder 7. Then after that 21. So our 21 value will be 91 minus 1 into 70. So we will write here 91 minus 1 into 70. So multiply by 3 inside the bracket. So 70 minus 3 into 91. Minus will be positive 3 into 71. So there is a 3 into 71 and 1 into 71. Total will be 4 into 70. So 4 into 70 minus 3 into 91. Right? Now in here, find the value of 70 from the equation second. So find the value of 70. So 252 minus 2 into 91. So minus 3 into 91. So just multiply by 4 inside the bracket, then you will getting 7 is equal to 4 into 252 minus 8 plus 3. That means 11.91. Here 91 is given 8 times, 91 is given 3 times. Total will be 11.91. Now 7 is equal to 4 into 252 minus 11. Now we need to calculate the last remainder 91 from the equation 1. So 595 minus 2 into 252. Just write here and solve this. 4 into 252 minus 11 into 595 plus 22 into 252. So 22 plus 4 will be 26 and minus 11 into 595. So just look at the question. Express in the form of 252m plus 595n. So we are getting our expression 252 into m plus 595 into n. So m will be 26 and n will be minus 11 here, right? So there is a 8 marks question. This question is of 8 marks, right? So first just see which one is smaller, and a smaller one divides larger one. So write quotient, remainder, then choose again quotient and write that quotient in the terms of remainders. So repeat this process again and again, then you will get your GCD. Now if remainder is 0, then second last equation remainder will be your GCD. Now, right? So for the form or expression, you will choose the remainders value. So just write second last remainder value. Then after the after the one write the other remainder value. Then other remainder value, and solve. Then you will get your final answer, right? So I think these two topics are sufficient for today, and I will discuss 2 or 3 examples more of Euclidean theorem algorithm. So there will be in our next videos, and in next videos I will discuss LCM topic plus Fibonacci series also. So just learn all these topics, and these topics on 16 marks questions, right? These topics will cover your 16 marks questions, right? So thank you.